What up, guys? What up? How was everyone's weekend? Technically, all of this is just a big, long weekend. Excellent. Good to hear. Anything fun, new, or exciting? Get some more lighting in here. There we go. Any adventures? Has anyone gone to the beach? Like before they closed? I know there's people that are like, I'm going. I don't care. Went mountain biking? That's awesome. Where did you go? Was it somewhere local or did you drive a bit to get there? Benelli. That's cool. See, that's a fun adventure. Now, in San Dimas and Glendora and stuff, do you guys have to wear a mask when you guys walk around? So, like that entire like San Dimas, Laverne, Glendora, Covina area, yeah, you have to wear a mask. So, when you went mountain biking, did you wear a mask? Because, like I said, I found it so difficult doing anything like outside activity, and it's just breathing straight into your eyeballs. Well, lucky you. I mean, like, dude, it's like you have to bring eye drops with you when you're running because your breath is just shooting straight up into your eyes. Okay, well that's good. Maybe it was like the idea that there was like social distancing going on, and so that's why maybe they weren't caring too much. I don't know. That's super interesting. Alrighty, so we're almost done. We are literally almost done. It's kind of crazy how almost done we are. And what I mean by we're almost done is technically to close the book. And we're done with the CPM curriculum. We have 2 more lessons. That's it. We have 2 more lessons. We have 11 2 1, and then we have 11 2 2. And that's it. We're done with this curriculum. Now, I'll toss in some good things that I think would be necessary to kind of help us a little bit in pre-calc. So we're not like done, but essentially, what I'm going to do is we're going to go over these 2 lessons. I don't think we're not going to do a test for this chapter because I can just include it into the final. We'll just do like a final review. That's what we'll do next week. Next weekend, through Alex, we'll take a final. And that's about it. We'll have those last 2 weeks and we'll do some lessons there. Yeah, it'll be good, but I kind of want to just kind of close the chapter with where we're at and take the final on that, and then just kind of move on to some of that pre-calc. So exciting! Congratulations! I mean, this is awesome. That this is where we start patting each other in the back. Because we're all done. Everything's good, and so but that's good. But yeah, so we basically end this going into 3D, the third dimension, and the 2 lessons that we go over, the first is how do we graph a 3D model, which is looking at the 3D plane, where if you imagine like the origin of a 3D graph is the corner of your wall. And so if that's the corner of your wall, if you're standing in the middle of your room and you're looking at the corner of your wall, going up that crack of your wall, that's your z-axis. The horizontal is your y-axis, and then coming towards you or past it, that's going to be your x-axis. And so when we plot a point, it's kind of awkward looking because we can't just like take the model and like go through and rotate it and see how that point is in space. But essentially, just like we would plot like an XY point, we do the same thing with an XYZ point. So looking at this first one here, look at that blurry graph. The point is A to 0. The point A is 0 to 0. So that means nothing in the X, 2 spaces in the Y, and then nothing in the Z. And so that point is actually right on the Y-axis. Now for the point B, which is 1, 3, negative 2, we're going to have 1 in the X and then 3 in the Y. So from here, it's going to go over 3. So 1, 2, 3. And then it's going to go down 2 spaces. So 1, 2. So it seems kind of weird. But that's basically the value. It seems like we could create like a new point. It's an approximation. Let me see if I can pull up a graph and we can look at that. It's kind of hard to do when you're just on a flat plane. So here's our 3D model. So basically the idea is, if we want to like look at it, right? There's our z-axis. It's typically facing like this. I believe the red is your x and your y is the green. So if I wanted to plug in the point 1, 3, negative 2, there's that point. Now it's kind of weird because, see, it's along the x-axis 1, it's along the y-axis 3, and then it's along the z-axis at negative 2. But when it's in that position there, it's kind of weird to tell, right? It's like, it's literally almost impossible to sit there and be like, if I drew this point and I said, what's that point? It could, because there's that depth and we don't necessarily have that depth, it's actually hard to measure. So generally speaking, you won't get a question that'll say, what's this point? Because like I said, there's that depth issue. It's like if I were to take a photograph and I hand you the photograph and I asked you, how far away were you standing in this picture? You don't know. You don't know how far you're zoomed in. You don't know the relative distance between things. Like you just don't know. Same thing here. I don't, based upon this, I could say maybe it's approximately 3, maybe see, like even this, I would think maybe it's 3, not the fact that it's 1, right? It's kind of weird, but that's just kind of the way that the 3D graphs work. So just know that you'll never get one where it's like, what's this point? You will get one where it's try and graph it. And like I said, you just move along the x, and so I moved 1 across the x, and then 3 across the y, and then from there I went down 2 points, and that's the orange is what the approximate relative value of where it's going to sit in that 3-dimensional space. Any questions with that? There's not really much to really go over that. I mean, we can graph 3D lines. We don't really spend too much in that in this class. Like, I could actually, I could say 3x plus 2y plus z equals 4. Now look at what ends up happening here, right? I get like this flat surface. And then what gets really crazy, and then we start, examining this actually in third year calculus, is like, what happens if I make this a square? Okay, well, that's a parabola. But it's like a three-dimensional parabola. It's not just a flat parabola. It's a parabola that actually comes out in space. Now what happens when I make this 4 into a 2? See, kind of adjusts it. Now what happens if I say I have both an x squared and a y squared? Then it kind of creates this cone. But the cone isn't solid. What happens if I said x squared plus y squared plus z squared? Then it kind of creates this oval shape. And then, but now what happens if I take the square from the y? Right? So now it's actually going to turn into a cone, but it just changes the direction. So you literally, in your third year calculus, you go through and basically based upon the x squareds, y squareds, z squareds, you can determine, which direction that it's facing, the shape that it's going to give you. If I make this is where it gets really crazy. Watch. Let's see. Maybe it doesn't create it. It won't create it. Maybe I have to zoom out more. I won't create it. Bummer. But you can actually go through and you can create some really crazy looking shapes as you start changing all of these. So I made this into 3x squared plus 2xy plus z. And now look at this. It kind of creates like this almost like mountain looking shape. Now what happens when I make that into a z squared? Right now it's almost like a two-dimensional cone. Let me zoom out a little bit. Right, it has a cone that's going in both directions. So I could start adding all of these kind of... So now it makes one cone bigger and one cone smaller. And even like... Oh, it won't work because it's three-dimensional. I don't know. It was kind of fun going through that in my third year calc class, just looking at all this different stuff. But basically with 3D modeling, now we can kind of see how things travel in a third-dimensional space. That's basically it. And then tomorrow, or tonight's the 11-2-1, we're just going to solve three-dimensional linear equations. And there's a strategy in how we solve that, and we're just going to go over that. So, cool. Any questions with number 1 before we move on? How to plot it? Like I said, you move along the x, then you move it along the y, then you move it along the z. Cool. Any questions on the adding, subtracting, multiplying, or dividing on rational expressions? And even if you don't have a question, is there one of these that you would like me to do? It's okay, giving you guys a moment to look at them. Number 5. Sweet. So let's look at number 5. So I'm going to start off just by factoring it. So for number 5, I'm going to get x plus 4 and then x minus 4, because that's how you factor x squared minus 16. The denominator, that's x minus 5 and x minus 5. Now because it's division, I have to multiply and you're going to flip it. So if I flip it, you get x minus 5 and x plus 2. And in the denominator, if you factor out a 3, you get 3 times x minus 4. Any questions on how I went through and factored that? So I just factored it, and then I flipped the division, the second fraction, because it was dividing. I did that first. And so now we have to reduce similar factors. And so I'm going to get x plus 4 times x plus 2 all over 3 times x minus 5. And that right there is an acceptable answer. Comments or questions on that one? Okay. No worries. Let's look at number 9. At least I'll set up number 9 for you guys. So for number 9, I have 3, and I'm just going to put it over 1 just to make it easier. Put like a space there for us. And then plus x over x plus 2, and then minus, and then 2 over, and I'm going to factor this one. So x squared minus 4 factors into x plus 2 and x minus 2. So now the 3 needs both the x plus 2 and the x minus 2. This one just needs the x minus 2. And the other one doesn't need anything. So then rewriting it, you're going to get 3 times x squared minus 4. I'm just going to multiply them together, which is 3x squared minus 12. And then distributing that one, you're going to get plus x squared minus 2x, and then minus 2, all over what the denominator is. So 3x squared and x squared is going to give us 4x squared, and then minus 2x, and then the negative 12 and the negative 2 is minus 14. We could check to factor. I don't know or think anything's going to factor though. So if I were to take out a 2, yeah. Factors of 14 that add a negative 1. None of them. So that's going to be our value. Comments or questions on 9? Okay. Any questions on 10 or 11? So these are going to be solving nonlinear equations. Dude, on my headphones, I got to get like a new pad. This one like just eats into my ear. So annoying. Number 11. So on number 11, x squared plus y squared equals 25. and I have y squared equals x plus 5. So we can actually do a substitution. Because I know y squared equals this, I can just plug that in for y squared. So I'm going to get x squared plus x plus 5, because instead of y squared, I now wrote x plus 5, and that equals 25. It's a quadratic equation now, so I'm going to subtract the 25. So I'm going to get x squared plus x minus 20. And so I'm going to get x plus 5 and x minus 4. So I get two values for x. So now with those two values for x, I want to know what the values for y are. So I'm going to plug in negative 5. So for y squared, and I'm going to plug it into this equation. I'm going to get negative 5 plus 5. So y squared equals 0. So then y equals 0. So my first point is going to be negative 5, 0. When I plugged in negative 5, it gave me 0. Now I'm going to plug in the next value. I'm going to plug in 4. So I'm going to get y squared equals 4 plus 5. And I get y squared equals 9. So if I square root both sides, I get y equals plus or minus 3. So then my other points, when I plugged in 4, it gave me two values for y. It gave me 3 and negative 3. So those are going to be my three different points. For any questions on number 11? Cool. On number 10, just to kind of start us off, probably what I would do, because if I have x squared plus y squared equals 25, and then y minus x equals 1, I would add the x, so you get y equals x plus 1, and then plug in the x plus 1 in for y squared. So you'd get x squared plus x plus 1 squared equals 25. Foil this out because it's x plus 1 times x plus 1. So that's going to give me x squared plus 2x plus 1 equals 25. Bring everything to one side, factor it, and solve from there. And then you get your values for x, plug them back in for y. All the rest would be the same as number 11. All right, we got some logs. Any questions on 12, 13, or 14? Any requests? Okay, well, on number 12, just to go over it real quick, you get log of 3x minus 1 equals log of 4 minus x. To get rid of the log, you do the inverse base. So then you get 3x minus 1 equals 4 minus x. Add 1, add x. So you get 4x equals 5. Divide both sides by 4. And you get x equals 5/4. Now you have to test it. So you actually have to take that 5/4 and you plug it back in. And you want to make sure that you get a positive value inside your log. If it's negative or 0, you cannot count it as a solution. If you plug them in, you should get positive on both of them. Therefore, it is an acceptable solution. So, well, cool. Awesome. I think we're done here. If you guys do have any other questions, just copy and paste it, post it in a Discord, and I'm more than happy to answer it. So, excited. We're almost done with the CPM book. It's so cool. I'm proud of you guys. I appreciate all you guys for showing up to the stream. I appreciate all the hard work that you guys have been doing. And I will see you guys tomorrow. Have a good one.